Now this is actually, I think, the down and dirty part of the graphing procedure. We need to make a sign chart for the first derivative, make a sign chart for the second derivative, make a combined sign chart, and then once we have a combined sign chart, we're going to sketch the graph. Now the very first thing I do, even when I have a simplified derivative, I like to write as a fraction as I can, because when we do a sign chart, what we like to do as much as possible is set the top equal to 0, set the bottom equal to 0, and that's going to give us the numbers that go on the number line. So I want to set the top equal to 0, I want to set the bottom equal to 0. Let's worry about the bottom just for a second. What number can you raise e to in order to get 0? The answer, there is no solution. Just a reminder, and you'll see this a lot, right? E to the anything looks like that, right? It never crosses the x-axis. So when I set the bottom equal to 0, I don't get any numbers. That actually means less to do. When I set the top equal to 0, we're going to get x equals 1 over a. So that's the only number that's going to go on the number line for the sign chart for the first derivative. So I'll just put it down here like this. We'll have to recreate this later. I'm going to put x right here. I'll put the derivative right there. The only number that goes here is 1 over a. Now I always like to take that number and plug it back into the derivative. Our derivative is over here. When you plug 1 over a into the bottom, you get e, which is positive. When you plug 1 over a into the top, the a cancels, you get 1 minus 1, that's 0. So what you get is 0 right there. Now how do sign charts work? We need to pick a number out here and a number out here and plug it in. Now a was positive, so the number out here isn't so bad. Usually I write in the number and I put it in a little box just to let you know it's not the x equals 0 axis and it has nothing to do with this number. It's just a number that's left over here. What do I want to do with that 0? I just want to put it into the derivative. Wherever I see an x, I get 1 on top, I get 0, I get 1 on bottom, right? So what I'm going to get is positive. That's what I care about. I now need a number that's bigger than 1 over a. The easiest number that you can write that works in here, there are other options, but I think this is the easiest one, is x equals 2 over a. Now what do I want to do with that 2 over a? I want to put it right here and put it right here. Now I put it on bottom, I get e squared, which is positive. When I put it on top, I put a 2 over a right here, the a cancels, and I get 1 minus 2. Well, 1 minus 2 is negative 1. The bottom was positive, and we get this. Now what did that tell us again about the derivative? When the first derivative is positive, the function is going up. When the first derivative is negative, the function is going down. So now we know exactly when the function is going up and when the function is going down. That's the first part of making the sign chart. We now need a sign chart for the second derivative. And fortunately we have, because we earned it, the simplified second derivative. So we're just going to write down the second derivative right here. And what was it? I think it was a times ax minus 2 times e to the minus ax. And as we did before, I want to write that as a fraction. The a stays on top. The ax minus 2 stays on top. The e to the ax goes to the bottom. Now, I just want to set the bottom equal to 0. That might give me a number on my number line, but it doesn't. You can't raise e to any number and get 0. Not even complex ones. When I set the top equal to 0, we get x equals 2 over a. X equals 2 over a. So that's the only number that's actually, see, 2 over a. That's the only number that's going to go on our sign chart for the second derivative. So I'm going to draw a number line for the second derivative. I'll put x right here. I'll put the second derivative right here. 2 over a goes right there like that. When I take a 2 over a and put it in the bottom, e to the something's always positive. Don't have to worry about that. When I put 2 over a on top, I put it right in here. The a cancels. I get 2 minus 2. I get the 0 like I should. Now, we need a number less than 2 over a and bigger than 2 over a. It is true that 1 over a is less than 2 over a, but x equals 0 is still easier, and let's go for the easier. Let's do that. When I put in a 0 in for x, I get negative on top. I get positive on bottom. Oop. And that's going to give me a negative fraction. I need a number bigger than 2 over a. How about 3 over a? This is just remembering this from algebra. This is how sign charts work. Now when I put a 3 over a on the bottom, e to the anything is always positive. Don't have to worry about that. When I put a 3 over a right in there for x, the a's cancel. I get 3. 3 minus 2 is 1. 1 times a is positive, so I have positive over positive. I get that. Now, what does that tell us about the function? Remember, the second derivative doesn't tell us when it's going up or going down. It tells us when it's concave up or concave down. So up until 2 over a, we have something that looks like that. After 2 over a, we have something that looks like that. All right, so now we have the two sign charts for the first and second derivative. We need to put them together like we did about 3 weeks ago when we were talking about plain old derivatives. So what I'm going to do, hopefully leave myself enough room. Again, this is just x's. The only important points from the first and second derivative were 1 over a and 2 over a. Make that look like an x. I want to know what was going on with the second derivative. I want to know what was going on with the first derivative. I want to know what's going on with the function. And remember, this is exactly how we organized it about 3 weeks ago. That's the difference from 3 weeks ago till now. We had to earn the sign charts. It was pretty bad. So let's see here. This is supposed to look like 1 over a. Let's make it look like 1 over a. Good. Now what happened with the second derivative? The second derivative, it was negative until 2 over a and then positive. What about the first derivative? The first derivative was positive until 1 over a and then it was negative. Now we can put these together and you get a good shape. Now, when the second derivative is negative, it's concave down. But we don't get the whole down graph, right? We only get that part where the function's going up. So it just looks like that until 1 over a. In the second part, it's still concave down, so it still looks like part of that graph. But now the function is going down because the first derivative is negative, so we get this piece like this. And in the third piece, we finally get a piece of graph that's concave up, which looks like that, but not the whole piece. We only get the piece where the derivative is negative. See, the derivative is negative, right? When the derivative is negative, the function's going down, so we get something like that. So we can draw, I think, a very, 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 very basic graph. We will fix this in the last part, but meanwhile we have something. And why not? Why not show our something, right? So 1 over a and 2 over a, right? We have something that's going up like this, and then down like this, Lord knows how far, and then something like that, if you can see that. Right, so it's going to go up and then down and then something like that. In the third part, we use the intercepts and the end behavior to fix the stuff that's wrong with this and get the final graph.